Hi, thanks for joining me today. I've got a fun problem from the Cambridge STEP. This is the admissions test you have to do if you want to study maths at Cambridge University. Bar magnets are placed randomly end to end in a straight line. If adjacent magnets have ends of opposite polarities facing each other, then they join together to form a single unit. If they have the ends of the same polarity facing each other, then they stand apart. We want to find the expectation and the variance of the number of separate units in terms of the total number n of magnets. So here I've got an example where n is 4, so I randomly lay these 4 magnets out, and let's imagine it ends up in this kind of scenario. Well, these two magnets here, well, they've got south and north facing each other, so they would join together. But this guy here, this wouldn't join along because that would repel with the s, so that would be a separate unit. And these guys again would repel. So in this instance, we have 3 separate units. And we want to know, well, what's the expectation of the number of units, and also what is the variance of the number of units. If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so we're going to start by saying x is going to be the number of times the polarity stays the same. So number of times polarity doesn't change, going from one magnet to the next. Oh gosh, my handwriting is horrible. The number of times the polarity stays the same. So for example, here the polarity has changed, so we wouldn't count that, but here the polarity has stayed the same, and here the polarity has also stayed the same between consecutive magnets. So in this case, x would be 2. Okay, cool. So now what we're going to do is think about what x is. Well, if we imagine we place down the first bar magnet, well, once that's, if it's like the way I've laid it out here, where south is facing to the right, the second bar magnet, that has a 50% chance of, being attracted to the S, or 50% chance of repelling it, because these are all placed down completely randomly. And so the same is true here. Once you place down this second bar magnet, this third bar magnet has a 50-50 chance of being attracted to this guy or not. And so what we realize that is, because we've got, well, how many potential gaps here? We have n minus 1. And so x is simply a binomial distribution. There are n minus 1 chances for the polarity to stay the same. And each time the polarity stays the same, or the probability for the polarity to be the same between consecutive magnets is just a half. And each kind of gap here is independent of any previous gaps. Because if we think about adding the bar magnets one by one, each randomly, none of them really impact the other. So x is distributed binomially n minus 1, comma, a half. And now we can just think about the number of units here. So if I call y the number of units, the number of separate units, the thing that we're trying to consider, y is simply x plus 1. Because if we have, for example, no polarity changes, in other words, x is 0, that means that the polarity, if x is 0, that means that the number of times the polarity stays the same as 0. That means every single time it's alternating, and that means that this is going to all group together to make one big strip, and so y would be x plus 1. On the flip side, if x was, let's say, n minus 1, so the polarity is the same every single time, then all of these magnets will be individuals, and therefore y would be n. And so this makes sense that y is x plus 1. And y is the thing that we're interested in. So we can just calculate the expected value of y. Using the linearity of expectation, this is just the expected value of x plus 1. And since x is a binomial distribution, the expected value of x is just this guy times this guy. So this is n minus 1 divided by 2 plus 1, or in other words, n plus 1 over 2. So the expected number of separate units that we generate here would be n plus 1 over 2. And now how about the variance? Well, this is maybe slightly less interesting, but the variance of y, again, we can use properties of variance. This is just going to be the same as the variance of x, because adding or subtracting a constant doesn't impact the variance. And the variance of x here, well, to work out the variance, you do the n value, which in this case is n minus 1, multiplied by the p value, which is a half, multiplied by 1 minus p, which is also a half. And in this case, that would be n minus 1 over 4. And that solves this problem. So quite a nice problem when you realize how to do it. And I think this is, I quite like this problem. This was from step 1, so not step 2 or step 3, which is, so step 1 they don't even make anymore. It's supposed to be the easier one, but obviously still filled with really interesting and challenging problems like this one. Anyway, we'll wrap the video up there for today. If you have enjoyed it, please do give it a like, and if you're new to the channel, please do subscribe as well. Thanks so much for watching. I'll catch you in the next one. Have a great day.